I'm David Alzofon, and I'm here at Falcon Space to talk about my dad, Dr. Frederick Alzofon, who did significant work in the study of gravitation and the technology of gravity control. And I'm here to tell the historical development of that, along with an update on the most recent activity. So, looking back to my earliest memories of my dad, we were living on Point Loma in San Diego. He was teaching calculus to the Navy for artillery. And one of my first, most blinding impressions of my dad was how he saved or attempted to save a little blue jay. A little blue jay that had been attacked by other blue jays out in front of the house. And the scene is imprinted on my mind. His kindness to animals, I think, was one of his most outstanding traits. Later on in Santa Barbara, he jumped into the yacht harbor to save a dog that was drowning. And lots of people were standing around doing nothing, but he jumped off the pier and pulled the dog out of the water. And people cheered him. So that also illustrates one of his most salient personality traits, which was his, he thought for himself. He marched to the beat of his own drummer, and that was just as true in physics as in everything else he did. I'm trying to give you a sense of the way he thought so that when we get into the specifics of his history, you might be thinking about the way these patterns of thinking were always there, but how they developed under the influence of his professors at Cal Berkeley and in the aerospace industry, where he carried out a lot of original research. And then we'll come to the story of anti-gravity, which, by the way, is a very bad word, and I'll explain exactly why in due course. Now, going back to his early life, he grew up in Detroit in an area he called Hell's Kitchen. I think it was actually on the border of Hell's Kitchen, a Jewish neighborhood and a black neighborhood right next to each other. And there was conflict there, and he was surrounded by it. I don't think he was touched by it. I think he spent most of his life with his nose in books of various kinds. And by the way, he didn't carry any prejudices against anyone. Continually throughout the entire time that I knew him, he emphasized our common humanity. And this led to some very important decisions in the development of gravity control. He got offers from powerful interests within the government to research gravity control starting in 1960 with publication of a paper I'll mention. And in about 1994 also from the deep state, the dark side of the force. And he turned them both down, even though the money was unlimited, and he wanted nothing more than to research gravity control, because he didn't want his invention to be used for weaponry. He didn't want to see it go into a black vault in the Pentagon and reemerge with like a stealth bomber to bomb the hell out of people he didn't even know. That wasn't what he envisioned. What he envisioned is, interestingly enough, very much what Elon Musk talks about when he, and Jeff Bezos, about the commercialization of the space frontier through colonization, space mining, space stations, space tourism, all of that. And when I was about 8 years old, he told me why that was completely unfeasible because of the laws of physics. They will, what's that?
The rocket equation.
Yeah, you got to use so much fuel to get so little payload out into space that you burn it all up and then you're floating in space and you have to coast back to Earth again. And that's still the paradigm, isn't it? Every time you hear about a space launch. controlled flight into space at any speed you desire, carrying a big payload out to a space station, is not possible now. And so the commercialization of space has been retarded by the laws of physics. And what he told me when I was 8 years old, though I couldn't possibly have understood the full implications of it, was there is a solution, and that is to control the force of gravity so that you don't have to expend so much energy launching rockets, and you have fuel or some kind of propulsion left over once you get out there for maneuvering. And that is the goal of gravity control, among other things. However, I do think I should mention that gravity control, if it's fully realized, will completely change the face of terrestrial transportation as well. For example, it would mean the merger between private aviation and automobile type transportation, where everyone could fly instantly from wherever they are to locations thousands of miles away, maybe to visit relatives, or maybe to go on vacation or fishing. And right now that's not too practical, but the energy required and the technology required for gravity control make it feasible. So let's go back to the 1950s. Just before the 1950s, in the 1940s, Fred was a student of J. Robert Oppenheimer, which is apropos for the present moment because of the film Oppenheimer. I heard many stories about Oppenheimer as I was growing up. And one of the points that Fred emphasized about Oppenheimer was that he never made any major theoretical contributions to physics, and this irked him no end. The makers of the film, I believe it was either that or Oppenheimer's biographer, said that he was kind of caught because he was born at a time when most of the major contributions in physics were thought to have been made already. And so he wound up commentating on various aspects of physics, but creating something new, he didn't do it. So he went over to the dark side and invented the atom bomb. And I think that was a lesson to my dad. I'm not even sure he invented the atom bomb, but he led the Manhattan Project. Now, my mom was involved in the Manhattan Project, and there are some anecdotes about her. She did not know what it was about, but she was exposed to radiation at the University of Chicago. So the impact of the Manhattan Project on our family was significant from the time I was a little kid. All the secrecy involved in it, there was a legacy of that. Also, my father had a top secret clearance because he was working in aerospace. And there were some comical sessions when I was growing up when my dad would tell all of us kids, "Don't ever mention my work on the phone because they're listening in." And we used to giggle and laugh. Who's listening in? He said, "The FBI." Well, he wasn't paranoid. They told him they were going to be listening in. So he didn't want us mentioning his work. The laughable part of that was none of us knew what he did. My entire childhood, there were various kids at school. One would say, "My dad's an airline pilot." One would say, "My dad's a garbage man. My dad's a baseball player." It was something specific you could visualize. I didn't know what to say about my dad because I had no idea what he did. He just went off to work in the morning at Lockheed and came back at night and promptly went to the back of the house to his study, which he built himself. It was a dog kennel, and he pulled all of the dog kennel stuff out and put in bookshelves and a typewriter, a Royal portable typewriter. And he sat in there every night after work, working until my mom made dinner, and then he came out and sat in the kitchen briefly and went back into his bedroom to work on physics more. And so when I say he was one of the most highly trained and self-trained physicists in history, I have no doubt, because every waking moment of his life was devoted to physics and to the scientific method, which is another topic I want to hit before we come to gravity, right about just before we come to gravity.
What about Cal Berkeley? What was he doing there?
Yeah, if you could go back to the wartime period, his discovery of his heart murmur and how he ended up doing research at cyclotron.
They're connected, so one answer will answer the other. Yes, okay. The question concerns what Fred was doing at Cal Berkeley. Well, he came out of technical high school and went to UCLA, worked in a prop shop for the movie industry while I was going to UCLA, got his master's in math and physics, and then he went on to Cal Berkeley, which at the time was entering the golden age of physics at Cal Berkeley, with teachers not only like J. Robert Oppenheimer, but a cat named Victor Lenzen, and some others like David Bohm, J.W. Weinberg, Robert Millikan was bopping around there, going between Caltech and UC Berkeley, I believe. Robert Millikan sat on my dad's PhD committee, Nobel Prize winner in chemistry. So what Fred was doing was going for his PhD in particle physics. And he went all the way through the program to his oral exams, and for reasons I'm not entirely clear on, he had a falling out with his professors at in the physics department, and he jumped ship and went over to the mathematics department, which at the time was headed by Griffith C. Evans, the namesake of Evans Hall of Mathematics. And he started the whole process over again, not from scratch, obviously, he had a lot of mathematics, but he got his PhD in applied mathematics eventually, 1956, I believe, or 54. I guess I'd have to look it up, but back in the 50s. And he put the two disciplines together to become his unified field theory, ultimately. But by the time he was out of the physics department, and I won't forget about the issue of the war, he was thinking about unified field theory. And the reason he was largely because of his awareness of the problems with general relativity. Whereas, I can't speak for every student in his surroundings, but he didn't accept them. He wanted to rebuild physics at the juncture between special relativity and general relativity. And what he did was unforgivable. He severed the two of them and discarded general relativity, and he boosted the power of special relativity to the realm of high energy interactions between particles, where matter is destroyed and created, and this was enough to show the unification of all the four fundamental forces and give an explanation for the force of gravitation. And now let me cover the history between 1942 when Oppenheimer left, Fred got his draft notice, and 1960, which was a big date in this whole narrative. So I was asked, what about what Fred was doing during the war? Well, he went in for his draft notice. He expected to be going to Europe next and fighting Hitler. And instead, they gave him a physical exam and told him he wouldn't live to the age of 30, which turned out to be slightly off since he lived to the age of 93. But at the time, he left the draft office newly advised of a heart murmur, and he thought he had only a limited lifespan left. And as has been pointed out to me, perhaps that was one of the drivers behind his interest in the ultimate questions. And throughout his life, I would say, he was always talking about the ultimate questions. But he had two particular tools that enabled him to get answers to the ultimate questions, and these were mathematics and the scientific method. And he practiced these so much that he developed almost Newtonian powers of generalization and abstraction that continually astonished me throughout my entire life. I mean, I've written now 2 books on Fred. I in no way consider my intellect in any way comparable to his, probably because he was brilliant and probably because of his training. And I will come to his major influence in scientific training in just a moment. But the scientific method was one of the tools, and I mean, he got these, he would apply it to everything, including sociology. Towards the end of his life, he was rewriting the social contract by Descartes according to a physicist's point of view. And just before he died, he threw out all the notes he had made on that because he said it was too dangerous. So when I went to look for them, they weren't there.
Tell us a little bit about your father's influence in science.
Okay, as soon as he changed from the physics department to the mathematics department, he got a new professor who knew about physics and mathematics and the philosophy of science. In fact, he had so many PhDs, they called him the PhD collector. And he was a direct student of Bertrand Russell and Albert Einstein. And he had an indistinguished background. He was born in San Jose. His name was Victor Lenzen. And he isn't talked about much these days, but he's the one who taught Fred about the scientific method. And most of us tend to think of the scientific method in broad and simple terms. You have a general theory, you have a hypothesis, you test the hypothesis with an experiment, and if you're successful, whoopee, you just explained a natural phenomenon. And then you write a paper about it and go on to the next thing. Actually, Fred, when he explained the scientific method to me, outlined 15 steps in the scientific method. Almost most of those aren't talked about. Now, in one of the books, I do list all of those. I believe it's Gravity Control with Present Technology, where I list all of those. That's this one. This book is largely made up of unpublished writing by Frederick Alzofon. I always called my dad Fred because I listened to the adults in my environment and they didn't discourage me, they thought it was funny. So I wound up calling my dad Fred. Anyway, I don't have to consult the exact page, but there's a lot about the thinking that led him to his theory of gravitation. And what is nice and neat about his theory of gravitation is that it follows all the rules of Victor Lenzen. It is compatible with past theory, which means, for example, it's covariant with special relativity, which is accepted as established fact. It's one of the most and best supported theories in the history of physics. So he doesn't try to mess with special relativity. Instead, he made his theory covariant in accord with the demands of special relativity. And it's also visualizable. You can explain it with a sketch on the back of a paper napkin, which was one of his qualifications for a good scientific theory. It's mathematical, though you don't need the mathematics necessarily to understand it. It's thoroughly based in strong applied mathematics, as you would expect. And because it identifies the relationship between the force of gravitation and all the other forces, it provides the entry point for affecting the force of gravity with one of the other fundamental forces, electromagnetism. Now, there is nothing in the history of science to show any relationship between electromagnetism and gravitation, though many people have tried. A super strong magnetic field may produce some odd results, but if it affects gravity at all, let's say it did. Let's say you could affect gravity with with electromagnetism. Nobody would know why, but within the framework of Fred's theory, you would know why. You would know exactly what connected them. Now, what we do here with this device behind me, this is an electron spin resonance device, which is capable of producing the gravity control effect. At least we hope so. We're about to run some experiments here. If we're successful, then we are duplicating the 1994 experiments that Fred ran, and of course I'll be coming to those in due course here. Now, let's go back to 1942. Fred's working at the cyclotron. He's thinking about reality, the subatomic reality, because that's what you do with the cyclotron. You ram particles into each other and see what happens. And that made him think about all of these little tiny particles that emerge from collisions, meson, boson, quark, scion, who knows? I don't know the whole list, but there's quite a long list now. And he thought, well, below the level then of elementary particles is the level at which these particles form. And there is evidence that there is creation and annihilation of particles going on at this subatomic level on a scale of time that is so infinitesimal and a scale of space or volume that is so infinitesimal that it can't be observed. Fred says this is where the force of gravity originates, in these what we call virtual processes. Now, many scientists argue about virtual processes and say, well, they've never been identified with the force of gravity before. Well, you've never had a theory that identified them with the force of gravity before, or that visualized virtual processes in quite the same way that Fred did after his years at the cyclotron. So I've looked up virtual processes on the web. They're very difficult to investigate, so most people don't have any clear idea of what they mean. Fred knew exactly what they meant. They're a substrate of random electrodynamic activity beneath the particle state, or elementary particle state. So there's a kind of a shading of reality from at the very lowest level that we can imagine now, which is virtual processes, up to elementary particles where maybe one of these momentary creations of a particle spins on itself and catches its own tail and becomes a permanent knot of electromagnetic energy. What is this field that is the home of virtual processes? And it goes by several different names: the zero-point energy field, the polarity of the vacuum, the virtual process field, where subatomic particles are being created and annihilated on an infinitesimal scale, a negative factor extending out to 14 points. So it goes by different names. We don't understand it that well. We can't take a picture of it because it's more minute than a light wave. However, we can see the effects of it, and what Fred was working on involved, it got him thinking about this substrata of reality beneath the elementary particle level. And elementary particles are kind of the froth on top of that layer. And he began to think much more about the layer where there was so much random electrodynamic activity, but no solid matter. Now, reality such as we know it exists in only two forms: solid matter or radiant energy. There is nothing observable, and at any rate, that is not in one of those two categories. On the other hand, as Einstein pointed out, solid matter is condensed energy, and you can blow it apart in an atomic bomb and release all of that energy, and it is quite astronomical. All of the energy bottled up inside even one atom. So we could say about reality that it's either radiant energy or it's condensed energy. There's two forms, but it's all electromagnetic radiation. And that means that all interactions are electromagnetic. Now, doesn't that suggest that gravitation might have some relation to the virtual process cloud? Because you could say the same things about gravity that you could say about the virtual process cloud. You could say that it extends from every elementary particle to an infinite distance. However, that's the, I believe yes, it's the inverse square law that governs the density of that energy that spreads out from a particle. We tend to think of particles because of our educational system as a billiard ball, and we don't think of it really as an energy packet that's surrounded by a cloud of virtual processes. This is the way he was thinking of it back in 1942. So if you get, say, one particle, the virtual process cloud isn't particularly significant in its interactions with other particles. Electromagnetic forces, atomic forces, all those other forces are much stronger in a sub-microscopic scale, subatomic scale. However, when you aggregate a large number of particles together, the virtual process cloud begins to become very considerable. In fact, it would behave exactly the way it did around a single particle. It would diminish at the rate of the inverse square law, which is the same as the gravitational law, which suggests something pretty strongly that there's an interrelationship between them. So the virtual process cloud, another important point to make about it is it's electrically neutral and it pervades everything. This is something it has in common, two things it has in common with gravitation. So this is a little preview of his thinking about gravity, but all of these thoughts occurred to him during this period at Cal Berkeley, but they were generalized thoughts. They weren't yet mathematically coordinated with the special theory of relativity. That didn't come until much later, around 1954. He wrote a letter to Albert Einstein and never got a reply because Einstein unfortunately died without ever replying to his letter. He then was walking around Caltech in 1956, and he saw that Richard Feynman, well, I'm sure he knew that Richard Feynman was there. Richard Feynman was a hero of his, like Victor Lenzen. These were the two main figures in the development of, he modeled his thinking after the two of them. Richard Feynman and Victor Lenzen. He dedicated his final paper on physics to Richard Feynman. And part of the reason for that was the encouragement that he got from Richard Feynman when he went in to see him at Caltech to argue his unified field theory with Richard Feynman. Well, Richard Feynman could be a tough critic, I think you know. And he did have open office hours, which made it possible to just walk in and see him. Didn't have to get an advanced appointment. And Feynman was tossing a tennis ball against the wall, which he kept doing during their conversation. And then they started to get more serious in this discussion. And Feynman tried to poke holes in Fred's theory, and he managed to point out, some work was needed before it could be published. But he said overall he was really impressed. And so Fred left that meeting with a determination to publish a paper on at least one aspect of his unified field theory, which was gravitation. He thought his biggest contribution was in gravitation. He did write that paper. It was published in 1960, and this was a pivotal date in our whole story. Okay, the paper came out. We were living in Palo Alto at the same time, and he thought it was worthy of research. And just coincidentally, the U.S. Air Force was doing some research of their own on gravitation research worldwide. And the reason for that was there was a lot of Cold War paranoia when Moscow said, we've got anti-gravity ships that can fly at will into space like a jet plane and come back whenever they want to. And ha ha ha, we are going to bury you capitalist pigs. So Air Force got worried. And they commissioned a survey by a physicist named Dr. Maurice Garbel. I met Dr. Garbel when I was 10 years old at a restaurant in Palo Alto, where he told my dad that your theory is the only one that I saw worldwide since the time of Newton that has any prayer of an engineering application. Namely, because if you interfere with the virtual processes, well, you should be interfering with gravity. It's obvious. But none of the other theories really had any kind of a causal connection between, say, the electromagnetic spectrum and gravitation. Okay, so he said the problem is there is no way in hell that your theory will ever be allowed in the door of a university. So they're not going to do any research on your theory, though I would like to see it. And that's when Fred, I think he made contact with NASA Ames or vice versa and wanted to talk about doing research into anti-gravity, which is what he called it back then, because he read a lot of science fiction magazines. He had bookshelves filled with every issue of amazing science fiction and fantasy and science fiction, every single copy of every single year. And by the way, I sat in his study all the time reading them while he was clacking away on the Royal Portable. He said, you can stay here as long as you don't make any noise. So I'd sit in there and read these science fiction magazines. And anti-gravity certainly figured in a lot of stories. In other words, the human mind anticipates that we will someday control gravitation, and it will be the ultimate liberating technology, because it will give birth to the human race as a space race. It's going to be graduation from the cradle to high school, at least. There are probably other things far beyond that we can't imagine at this point. But we will get off the planet. And that was the dream. And by the way, my mom, I want to give her credit because she shared that dream as much as any of us. She told us, your father is on a very special mission, so if he goes in his room after dinner, he doesn't play with you or participate in much table talk, it's because he's very busy. And so that's your dad. Just enjoy everything that you can about the family relationships. And actually we did. We had a lot of good times with Fred. I don't need to go into the family album. But he was a very reclusive person who marched to the beat of his own drummer, and he wouldn't let anything get in his way. He was single-mindedly devoted to the technology of anti-gravity. First the theory, then the applied technology, and that's what he did for the rest of his life. And now I'm going to explain the transition from the theory, 1960, to the applied technology, 1976. Okay, along about 1976, I was living in Menlo Park, California, and there was a bookstore there called Kepler's Bookstore, which specialized in every kind of rare and unusual and interesting book under the sun, besides all of the bestsellers, the routine kind of stuff, the mass market paperbacks. And there were more books in that store than you could shake a stick at. And I was in there all the time. Now, in 1976, I was 26. And I walked in there and I had UFOs on my mind. I always checked the shelf for the latest publications in UFOs, and that's where I found a book by one James McCampbell, nuclear engineer, who lived in Belmont, California. I found out by turning to the back of the book. I eventually got to know Jim McCampbell, but at the time I didn't know him. All I knew was there were some very interesting ideas in his books. And one of them was that microwaves had something to do with UFO propulsion. And he used a lot of evidence to show that UFOs were giving off massive amounts of microwave energy. He used the physical symptoms in people who stood near a landed UFO. He used, above all, a massive data that was collected by a electronic countermeasures B-57 training mission over the Gulf of Mexico in 1957. And he published all of this data, which had never been published before, because a report about that flight made it into the Condon Committee first draft of their report. And somebody saw it and their hair flew out like this, and they said, "Get that out of there!" And they yanked it out. So it's not in the final published report of the Condon Committee. But thanks to Jim McCampbell, it wound up in his book. And it gave the frequency of the microwave field and the pulse rate, because it was pulsing at almost, I believe, an audio frequency, and the amount of energy it was giving off, the polarity, a lot of other little details that aren't particularly meaningful to me, but they were certainly meaningful to Fred. Because when I sent him the book, he went into his study, and a couple weeks later, he felt he was on the verge of an insight. So he went to a technological laboratory in the Long Beach area, and he was walking among the shelves, looking at books for this particular state of matter, as he put it to me. And one of the books just flopped on the floor. And that book was right here, the Bible. C.D. Jeffries' Dynamic Nuclear Orientation. The pages in this book are really interesting because they look like this. Greek and graphs. Greek and graphs. It's not light reading, that's what I'm trying to say. But to Fred, it was a feast. He found the state of matter he was looking for, and he decided he decoded the technology that propels UFOs. There were no UAPs in those days. The term UAP, by the way, is just an effort to get the pilots out of the picture. You're just talking about a machine. Unidentified Aerial Phenomena, I guess it's changed to Unidentified Anomalous Phenomena. They're making it even more sanitized than UFO. Unidentified flying object is mixed up with little green men, little gray men, tall white men.
So where did he go from there, from the C.D. Jeffries book?
So where did Fred go from the C.D. Jeffries book? I'm reminded to keep on track here.
We also see them underwater, though, too.
Yeah, they're multimedia, and probably for the same reason that they bend the medium around them so they can go underwater at 190 miles an hour and in the air at 10,000 miles an hour. But let's stay on track with UFO technology. What was your question again, Mark?
Where did he go after reading this book?
Okay, where did Fred go after reading the C.D. Jeffries book? Thank you. What he did was he worked the theory out in great detail, obsessive detail, and a few years later he filed a patent on anti-gravity. He called it anti-gravity, and I'm going to tell you when he jettisoned that term. Because language is everything, it turns out, even in physics. He filed the patent. He was told by the patent attorney that it was a sure thing, that he would get the patent, and he was very worried that the government would step in and squash his patent application under a pile of top secret labels. So as fast as he could, he published this paper, which is AIAA 81-1608, Anti-Gravity with Present Technology, Implementation and Theoretical Foundation, AIAA Colorado Springs, for many people will recognize the significance of Colorado Springs. It was where Tesla's energy station was, where he was transmitting power wirelessly to light bulbs in a circle, and simultaneously put out the power at the neighboring town of Colorado Springs. I think it's kind of fate that made Fred deliver this paper at Colorado Springs. Now, the first part of the paper shows the clarity of his reasoning process. After that, it gets exceptionally mathematical and difficult. You have to have a background in physics in order to appreciate the rest of it, but I do recommend anyone can read the opening several pages and get an idea of what he's talking about. And if you don't understand any term, there are references on the web, and what I would do is, if you had trouble reading it, just circle the terms you don't understand. They're what decouple you from the line of thinking in the paper, and make up your own vocabulary list, your glossary, copy and paste, and you'll be able to understand the paper.
What happened next? How was it received?
Sorry?
How was the book received?
Okay, how was the paper received? Poorly. Fred went back home. He said it was like dropping a feather into the Grand Canyon and waiting for an echo. Nothing happened. And he was completely flabbergasted that he could publish a paper like this and get no response. So he decided to go out and seek funding. And that was the beginning of a long struggle to get funding. And he went to Jim McCampbell, as a matter of fact, and asked for Jim's help in putting in a proposal to the Energy Department. At the time, I believe it was run by William Bennett, but I'm not entirely sure. And McCampbell knew them, the head of the Energy Department, and he endorsed the application, the proposal. However, there was virtually no response. It was maybe a couple of sentences, and they didn't want it. Now, it could be that if Fred had been able to make contact with the right people, he would have been able to get funding, but one of the obstacles it did turn out was the word anti-gravity. If you mention that word, physicists would run for cover. They don't want their scientific work confused with something as science fiction-y as anti-gravity. So Fred changed the terminology to gravity control from then on. First inkling he got that anti-gravity was not a good term. And still, that was not enough. The 1994 experiment, now we got three main dates in the history of this whole venture. We've got 1960, the paper on gravitation, the meeting with Ames NASA, which I didn't go into too much detail about, but he walked out of it because they wanted to classify it higher than the Manhattan Project. You mentioned the Manhattan Project to my dad, that was a deal killer right there. He walked out. He did not want it used for weapons. He wanted it used for the commercialization of space. Okay, so that left him wandering around looking for a way to implement his theory as a technology, and that's when I sent him the ufology book, and he had that insight. And then in 1981, he published the paper defining how anti-gravity should work. Theoretical, and let's see, what did he say? Implementation and theoretical foundation. Very heavy on theory. Okay, and then he found somebody found him who was able to help him build a primitive apparatus that would test his theory. And they were so secretive. I did eventually find out who he was working for, but I don't want to mention them by name because they would prefer to remain anonymous. I respect that. So the important thing is that they set up the experiment under a lot of time pressure, and they ran the experiment and were quite astonished when the weight of the sample behaved exactly as predicted by the theory. Namely, it went down under 2 flashes of microwave impulse, it lost about 80% of its weight. And it was a very small sample, I must say. But that weight was attached to a super sensitive scale. The measurements were accurate. And what was happening was that the weight would spike upward and then go downward, and spike upward a little bit and then go further downward. It was this sawtooth pattern that was predicted by the theory, and got my dad so excited, and everybody else who was participating was very excited by the result. So they had a test of his theory, and it looked like it was correct, but it wasn't publishable. And having examined the reports, I could see that it would cause a cold fusion type controversy if he had dared to publish his results. And he was exactly right not publishing. However, he was encouraged sufficiently to try to mount the experiment a second time. Enter Mark here with the second run at the 1994 experiment. So I still have a lot of years to cover between the 1994 experiment, my dad's death, and Mark mounting this experiment today.
He was on this machine, actually, at a later date with Hathaway.
That's correct. In 1990...
so this was before the 94 experiment?
This was before the 1994. I just never thought of it. I just didn't think of the experiment with George Hathaway in Toronto, Canada. They too had a falling out. My dad wanted to do the experiment one way, and Mr. Hathaway wanted to do it another way. And so my dad walked out. As my dad told it, there was a slight weight loss, nothing as dramatic as the 1994 experiment. Mr. Hathaway was using a ruby crystal because of the inclusions of various metals in the crystal structure. And he felt that this would be an ideal way to excite the dynamic nuclear orientation, which is the mechanism for gravity control. And I will come back to that. But so this is the device. They didn't have anything quite this good for the second experiment. This is an electron spin resonance device manufactured by Varian. Coincidentally, Varian was quite close to where I grew up, and but I certainly never saw this kind of hardware on sale.
And this, your dad and your brother worked on this machine?
Yes, my dad, and the question was who worked on this? My dad and my brother both worked on this. My brother's name is Daniel, and he lives, he lives in Oregon.
And he was working with your dad?
Yeah, my dad was living in, Oregon at the time. So, but at the time my brother was not living there. He was living pretty close by though. And, but ultimately the experiments were done in Toronto with this device. And Daniel and I both went to work trying to get sponsorship for a redo of 1994, and neither of us were successful. Fred wasn't successful, and eventually he said he didn't have the energy for it anymore. He had scientific papers that he wanted to write. They took a lot of time, so he was putting gravity control on the shelf, which is where it remained until his death in 2012.
What was the problem getting funding?
What was the problem getting funding? What was the problem getting funding? The answer was that people who are putting up their money don't like investing in something as speculative as gravity control. They want to see a device that works. So the most common refrain heard in our efforts to get funding was, prove it out and I will back you. Well, by this time, of course, they had picked your brain for every trade secret that they possibly could. And if they had wanted to, they could have walked off with it. And I'm going to, well, anyway, that was one of the main problems. You had to have a device in order to get funding, but you had to have funding in order to get a device. How many times have we been to a job interview where you needed the job in order to get the training, and you needed the training in order to get the job, and you could never agree? And that's the way we experienced, that was our primary experience with investors. And when I was working in Silicon Valley, I joined venture capital clubs just so I could talk to venture capitalists. It's exactly what I heard over and over and over again. Another question that came up was, how am I going to make any money off of this? Which boggled my mind, because this is quite possibly the most valuable technology in history, probably capable of doubling the global national product inside of 10 years after it makes its debut. Imagine the amount of money tied up in a single asteroid, for example. They're mostly made out of planetary core metal, pure metal. There is an asteroid that is pure platinum blowing by here on a regular schedule, but we can't get on board it. And
there's a mission to the asteroid Psyche right now. It's leaving, I think, sometime this month, and that's the all iron metal asteroid.
And they plan to mine it?
This is just exploratory. They're going to go into orbit around it.
They're going to go into orbit around it. Well, if they had an anti-gravity device, they could easily maneuver until they were right on top of it and dive in with mining equipment and extract tons of ore from it and bring that ore back to Earth. See, it's all connected to commercialization of space. And we're talking about $1 trillion wrapped up in a single asteroid. Imagine how much space mining money there is to be made on the moon, on Mars, the asteroid belt. It's an inconceivable amount. Plus, there's the joy of scientific discovery. It's all available out there in space. You can put communications satellites in the L5 zone around the Earth, stationary orbit, and they could also be used for energy relay from the sun. See, the sun never sets in space, so you can turn solar energy into microwave energy, channel it back to Earth. Don't stand underneath the beam, please. It's not safe. You'll be fried to a crisp. But there's a lot of money to be made in space, and Elon Musk and Jeff Bezos wouldn't be messing around with it if they didn't think so. The problem is, once again, they're being held back by the laws of physics. We intend to rewrite the laws of physics here and get ourselves out into space.
Did you ever experience somebody who was very interested in this but went to confer with their scientists who were looking at general relativity and decided that this was hogwash?
Okay, Mark brings up a very good point. Did Fred or I ever meet with somebody who would refer Fred's work to an expert in the field of physics that we were interested in, namely gravitation, which meant general relativity? Yeah. Since Fred had lopped off general relativity from his theory, the universal verdict from the experts was that Fred was full of it, and it was ridiculous. And I can tell you from having talked to a number of them that they never even read what he said. They just got as far as the first page and saw what he was proposing to do, and their minds shut down. And the degree to which this happened is impossible to overstate. I had one physics Nobel Prize nominee now removed from the planet. He's gone on to higher spiritual development, but I used to see him very regularly in Palo Alto. And I handed him my dad's paper, and the next time I saw him, I asked him if he had read the paper. He took it out of his briefcase and threw it at me, and he began literally frothing at the mouth in anger. He said, "Your dad is full of bullshit, because what you're saying," and I said, "Why?" And he said, "Because it violates the second law of thermodynamics. If I put if I take a 100-pound sack of potatoes and I use anti-gravity to raise it 100 feet in the air, I turn off the field and it falls to Earth with all that kinetic energy, where did it come from? You invented energy out of nothing. That's impossible according to the second law of thermodynamics. And therefore, your dad is full of bullshit. Well, I felt pretty bad about that, but I decided to find out if my dad was full of bullshit. I suspected he wasn't, but I put it to him, and I have to admit, kind of afraid that maybe I had found a weak spot in his theory. I wasn't sure. It took him about 3 sentences to wrap the Nobel Prize nominee up in a little crumpled ball of paper and throw him in the nearest wastebasket, because what he had left out, he said, your friend seems to have forgotten the difference between an open system and a closed system. If it had been a closed system, he would have been right. The second law of thermodynamics would apply in such a system. But with a gravity control, we're working with an open system where you can transform energy and move it around. And for the time that you've moved the gravitational field out into a cloud around your sack of potatoes, it's not going to be subject to the force of gravity. And then when you release it, wherever it's released, the energy from the gravitational field will determine how much kinetic energy it develops as it drops to the Earth. It's an open system. Later on, I found an essay he had written about the most interesting research in physics is going on in open systems as opposed to closed systems.
Is it possible that it's actually sucking energy from the Earth's rotation around the sun? It's changing Earth's orbit by doing something like that.
Okay, Mark asks if the gravity control device.
No, making a sack of potatoes go weightless and then dropping it from 100 miles up would actually just move Earth's orbit, and that's where the energy would come from.
Oh, okay. Mark asks if this would change the Earth's orbit, and this is where the energy would come from. I suspect that my dad would say no, that we're altering the energy in the surrounding cloud of virtual processes that comes from the Earth, and we're just moving it aside so that it doesn't affect our sack of potatoes. And if that alters the orbit of the planet Earth, it's probably too minuscule an amount to be measured, because you're taking enough energy out of the gravitational field to make a sack of potatoes weightless. It's 100 pounds. Imagine the momentum of the turning Earth. It's unbelievably powerful. So the relative strength of these two activities is, it's a huge ratio, and I don't think one would affect the other. Anyway, as I visualize gravity control, it's a matter of altering the virtual process cloud that surrounds your vehicle, and that frees it from the gravitational field, and incidentally also frees it from the property of inertia. Because remember, Fred held that gravity was due to the random electrodynamic processes in the virtual process field surrounding the Earth. But those processes internally in an object are responsible for inertia, and that's why you have the property that Einstein identified as the, help me out, I can't remember, the equivalency principle. The equivalency of inertial mass and gravitation. If you're sitting in a rocket ship and it's accelerating at 1g, you're going to feel exactly as if you're in a gravitational field that's holding you against the floor because you're accelerating at 1g. And the reason for that equivalency is because the internal processes that give rise to your inertia are the same as the external processes in the Earth's gravitational field. And that explains the one-to-one ratio of the two phenomena. And it also explains, because you're canceling that motion in your body you are freeing yourself from inertia. And I'm talking about the random jittering of the subatomic, the Brownian motion. Mark says the Brownian motion, the random motion of subatomic particles in your body is causing inertia. This is described in this paper and in several other papers, and I did try to call it out in the book, the relationship between inertia and random electromagnetic processes. Remember, the whole universe is nothing but radiant energy or condensed energy, and it's all electromagnetic, and all interactions are electromagnetic. And yet we still tend to think of objects as categorically solid or radiant. That light bulb over there and there, they're all radiant energy. This is solid. Is it different? Not really. This is an electromagnetic interaction. There's some reason that my hand can't penetrate this, why this desk pushes back on my hand. That too is explained in here.
Tell us a bit about Fred's history, his who influenced him at Caltech?
At
Cal Berkeley, yes.
Cal Berkeley. Okay, so as I've said, Cal Berkeley was the golden years of physics at Cal Berkeley, and I wanted to mention Fred's main inspirations and influences. First and foremost, I believe, was Albert Einstein, and he just happened to be studying with a professor who had studied with Albert Einstein directly, a man named Victor Lenzen, Lenzen. Lenzen is not noted these days much, but at the time, Albert Einstein himself noted that nobody understands my theory of relativity, meaning special theory of relativity and general relativity, better than Victor Lenzen. And Lenzen wrote a popularization of relativity, and he also instructed Fred in the meaning of general relativity and special relativity. And when I heard Fred argue general relativity with professors who were well-versed, he clearly understood the foundations of general relativity better than the professors he was arguing with. But he was approaching the whole business of relativity from a different point of view than professors who were well-versed in general relativity. By that time he had his own theory, not of relativity, but of the relationship between relativity and the laws of physics. So who else influenced him besides Lenzen and Einstein? Richard Feynman, for one. Richard Feynman was alive. He was a hero of my dad's, and eventually Fred went to Caltech and had a talk with Feynman. So in the wartime years, he was working at the cyclotron and rubbing elbows with E.O. Lawrence, the namesake of the laboratory, the Lawrence Radiation Lab. And there were kind of good guys and bad guys in that environment, but he modeled himself after who he had the most respect for in terms of scientific knowledge. And the last influence I would point to would be Griffith C. Evans, the namesake of Evans Hall of Mathematics. That's who ultimately awarded Fred his PhD in applied mathematics. I was pretty late in the game. I think it was 1956 when he got his doctorate. And mind you, he had started working on that in 1942. In the meantime, he'd gotten married and had a kid, me, and my sister. And so life was very eventful. It always went on no matter what he did. And so he fought for the time to work on this topic that gained him nothing materially, namely gravitation, unified field theory. And in relation to that, the other things that he was well known for He was considered a world-class expert in the field of optics, in the field of heat conduction, and Sommerfeld's method, which was a way of analyzing refraction of radiation from objects of arbitrary shape. That was Fred's contribution to Sommerfeld's method. They said it was impossible, and he did it. Infrared non-destructive testing, they said, was impossible, and he did it. There were other aerospace problems that he tackled that he managed to solve. So he was known as a problem solver within the Pentagon's history of his work career. Also, one other problem he solved that they thought nobody could solve was the problem of the origin of turbulence. And that was also after he was retired. It was a 100-year-old problem, and they still didn't have an adequate explanation for the behavior of a flag when it's furling in the wind, or the behavior of a viscous fluid as it moves out in the wake behind a boat. They can model it on computers, but they didn't understand exactly the causality. And Fred was very big on causality. There had to be a physical cause for everything, and he included gravitation in that belief. But as I say, he never expected to gain anything by that. It was something he did strictly on his own out of a passion for it.
That was very good, yes. What traits do you think set your dad apart from his peers?
Okay, what traits do I think separated Fred from his peers? The independence of his thought, the way he questioned absolutely everything. He was not overawed by anybody. When I look at the graduating class in mathematics from Cal in 1945 roughly, and I think he's in that picture, he fit in perfectly. The total inattention to fashion, the pocket protectors, the kind of disheveled appearance, and eccentric appearance too, goofy grins, Coke bottle bottom glasses. He was part of that world, and all through his life he always wore the same raincoat, just like Columbo. Day after day after day. You might not be familiar with Columbo, I'm dating myself, but he was a television detective who wore a dirty old raincoat, and he would always bring down the high and mighty, the murderers who thought they were going to get away with murder because of their social status. He would bring them down, and Fred was kind of like that in science. He would ask questions that embarrassed and upset the most exalted figures in the world of physics. So that's in a nutshell. He was something of an eccentric as well. He was entitled to be. He loved nature. He loved animals, as I mentioned earlier, saving a dog from drowning in the Santa Barbara Yacht Harbor. That's one, but many, many other instances of that. And he always had a cat around, I think, until he felt that his end was nigh. He didn't want to leave any orphan cats around. And I always felt he was sadder for the absence of a cat in his immediate surroundings. So those are some of the things. His talent for abstraction and generalization was unmatched. And that was a result of a natural talent and training. And it applied to everything that he talked about. We often had phone conversations in the years that he lived in Oregon and I was in California, and those conversations were very one-sided. I would kind of sit and listen and say, yeah, every once in a while, because he would talk endlessly, and it was all interesting and it was all unexpected. He always had unexpected conclusions about politics, about entertainment, about literature. and everything else under the sun. It wasn't confined to any one field, but the quality of his thought was the same in every field he touched. This talent for gathering immense amounts of data and reducing it to a simple phrase. He did that over and over again, and I've never seen anybody else do anything like it, except perhaps Isaac Newton. And then again, you know, Isaac Newton was a hero to my dad, and he modeled his thinking after Sir Isaac Newton. And I guess those are the things that distinguish him.
Go ahead, that's really good. Tell us a bit about your book, The Top 10 UFO Riddles.
Okay, now, yes, we haven't even gotten into how gravity control works. But once you understand how it works, you understand why UFOs behave the way they do, and you have an explanation for all the things, almost all the things, that they do that has been noted as being against the laws of physics. So that was a consequence of figuring out the data from the 1976 book by Jim McCampbell, Ufology, which is online. You can look it up.
And the questions are on the back over there. You can read them out.
Why do alien engineers prefer the saucer shape? Let's deal with that one first. One day I walked into my dad's study and he said, take a look at that book on page 726. It was a surplus science book. I opened it up and there was nothing there but a parabolic antenna. He said, you know what that is? And I said, yeah, it's an ideal radar antenna. He said, do you notice anything else about it? And I said, no. Doesn't it look kind of like half of a flying saucer? So here's the secret to why the saucer design was chosen by our friends from other planets. This is a parabolic antenna shape. It's also an ideal way to project a radar signal. Radar is microwave. Here's another one. You put them face to face, and let's say you have a center pole generating microwave energy that is coming out the top, swirling around the outside of the disk and the bottom, and you have a perfect way, the most efficient way to engulf the hull in a microwave field. So, or let's say you've induced dynamic nuclear orientation in this hull, it's the way to sustain it with the minimum amount of microwave energy. And microwaves are dangerous. You want to protect the occupants of the ship from microwaves. This is simultaneously a convenient way to put a cabin out of the field. So this is the secret to why they prefer saucers or simply axial symmetry in their design, like the shape of a cake or the shape of a globe, a sphere, a cylinder like a cigar, and why, of course, they don't need aerodynamic equipment like wings, because they're not relying on wings to stay aloft. Once you reduce, I hate to put it this simply, but once you reduce the weight of a saucer like this, it becomes lighter than air. In fact, theoretically, you could reduce its weight and inertia to zero, no matter how big and how heavy it is. If you have enough power in the center of it, and apparently they have very good means of generating energy, you can engulf the entire saucer in the protective shield of the dynamic nuclear orientation. I'll explain how that works. But okay, that's why the shape is preferred. And that's why you seldom see anything other than something that has axial symmetry used by the aliens.
Let's go to question number 2.
Question number 2. How do the UFOs remain aloft without wings? Well, again, I said it. When the weight goes to zero, they become buoyant in the atmosphere. And then a very small propulsion from, say, a jet, a rocket, or the Earth's magnetic field would move them at incredible rates of speed or acceleration in any direction with no effect on the occupants because their inertial processes have been canceled. They're independent of inertia. They can make right-angle turns at the speed of sound and not feel a thing, nor will the craft come flying apart because inertia doesn't enter into the equations. So why do UFOs remain aloft without wings? They float. They literally float. And then they use secondary propulsion to zoom through the atmosphere and out into space as they choose. Why do alien craft fly like skipping stones? Well, remember I mentioned in the experiment in 1994 that the weight of the object in the chamber was going up, spiking upward, and then dropping downward, spiking upward, and then dropping downward farther. That is being shown in the skipping stone flight, the undulating flight path of UFOs. Okay, it depends on how well they can sustain weight cancellation. So if a UFO flies in a perfectly straight line, it's putting more energy into weight cancellation. But those original saucers that were seen by Randall, what was his name? At Mount Rainier. Kenneth Arnold, I believe his name was, Kenneth Arnold. They were flying like skipping stones. And he said, like stones you skip on the water, somehow this became flying saucers. And not all UFOs are saucer-shaped. The ones he saw had a lot of axial symmetry, but not completely. They had kind of curved wings like that. And so it was probably harder to maintain the field around them because of that shape, and that's why they were doing the undulating flight path. The buildup of energy leads to floating, and then the loss during the driving of the subatomic processes, the weight builds up, the saucer sinks, and then when you release the field, microwave field, random motions are causing a loss of gravitational energy. And this is all analogous, by the way, to cryogenic freezing. I want to say analogous. I want to emphasize the term. We're talking about something like cryogenics, but on a subatomic level where the processes were freezing or causing to cool down, lose kinetic energy, are the gravitational processes, virtual processes, which have a certain amount of energy in them.
Question 4.
Question 4. How do they accelerate from 0 to Mach 10 in an instant without killing the occupants? This question has been answered already. The occupants are free from inertia, just as the craft is free from inertia. Inertial forces are completely canceled for the craft and the occupants. So they can make right-angle turns or instant accelerations without turning the occupants to jelly inside of the craft. And this has been a big one that physicists have had trouble wrapping their heads around, but this is the solution. Why do car engines, radios, and headlights shut down when a UFO passes overhead? The frequency of the microwave energy, the magnetic fields tend to cause the current in tungsten lamps to fade out. This is essentially it. There's much more detail in here. I actually got this answer from Jim McCampbell in his book Ufology, and from a talk I recorded with him. So it's just another side effect of the UFO propulsion system. Nothing mysterious about it. I know that Steven Spielberg used it as a dramatic point in E.T., or rather Close Encounters, but nothing mysterious about it. The whole point of this book is to take the mystery out of UFO technology, so you can look at them as just like a electric toaster and not get overawed by their visiting the Earth at the current time. How do giant crop circles form in seconds? Okay, what happens in crop circle formation is you see these small globes passing over the fields, then they take off and vanish. And then a very strong microwave field comes down from above. How do we know? Because it incandesces the noble gases in the atmosphere and causes the atmosphere to glow. Often it's seen coming down from a rain cloud. They want to use that as cover. And that is the second part of making a crop circle. The globes spread particles of iron, microscopic particles of iron on the ground. These have been detected. And then the field, which travels in a spiral as it comes down, causes circles to form. And out of this combination of areas that are dusted and areas that are not dusted, and the circular pattern of the microwave field, the circles are made. Well, why is that? Well, they only have to drive the subatomic particles for a fraction of a second, and it will cause the crops to burn at the base. The little nodules they find at the base of, say, each stalk of barley or wheat or whatever is being affected. These nodules are caused by heat in the 1500 degree range, but only for a fraction of a second. So that is a result of the microwave field coming down from above, flashing across the dusted fields and causing the spiral motion to induce the circles in the crops. This can be duplicated. You could easily arrange an experiment to duplicate crop circle technology. And that's the end of the list of questions on the back. I think they're probably the most interesting questions. There's a lot more detail, of course, in the book. I'm looking for any other interesting ones. Nope, I've covered the most interesting questions. And there are some other interesting ones in here, but that's UFO technology for you.
And where can people get the book?
Where can people get the book? Top 10 UFO Riddles is on Amazon. I think it's strictly in print form. I'll have to catch up on the Kindle version, but I cut the price to the lowest level they'd allow me to cut it. So if you want a good book to read about UFOs, I suggest this one. Just coincidentally, I'm the author. There are some true UFO encounters in the back. For example, this thing I saw on Interstate 5 in California, the TR-3B. I didn't know the term TR-3B at the time. It was the year 2000, and it was midnight, March 12th, 2000, and I was driving on I-5 North when I saw these lights in front of me, just about at the same level as the highway. And then whatever it was coming on fast, and I thought it was a passenger liner that was going to crash, or that there was some kind of an airfield off to the side among the oil wells. There were some oil wells. It was Castaic, actually. And then the thing veered over the highway and passed right in front of me. And it looked exactly like Darth Vader's Imperial Destroyer. No wings, solid black instead of white, like in the movie. But the tail section was two triangles with two rockets in the back. However, when I say rockets, you imagine flame coming out. There was some kind of incandescent blue flame inside of the circular rocket motors, but it was not projecting out the back. And there was no noise as it passed over. And it was flying about 60 miles an hour. And as it went, it was rocking back and forth like this, like a galleon on the sea, Spanish galleon on the high seas. And it gave the impression that it was about to crash, but obviously it didn't crash. No pilot's cabin, and for some reason there was a pulsating red light on the underside of it, hanging from what looked like an armature that stuck down. Aerodynamic in the sense that it was like a surfboard fin, but there was a red light on the end pulsating like this. Pretty weird thing to see on I-5. There were bright lights around the edges too, like a Christmas tree, just a line. I haven't seen that on any of the other images of the TR-3B. And unlike the isosceles triangles of other triangle sightings, this was a very long triangle with a long point on the end rather than a perfectly symmetrical triangle with equilateral sides. That was one of them. The other one, the very first sighting I ever had was really impressive. It was in the Sierras. We were camped by a stream, and Fred saw this one too. There seemed to be a satellite passing overhead. It was 9 p.m., crystal clear skies, Milky Way in view, and one satellite passing overhead. There weren't a lot of satellites in those days. And we were talking about it, and he said, it's going the wrong direction. Most satellites you see go the other way. I guess this one was going from northwest to southeast, and that was unusual. Anyway, as we were looking at it and talking about it, it came to a complete standstill in the sky. Satellites don't do that. And as we were talking about why it had come to a complete standstill, maybe 10 to 12 seconds later, it took off. But it didn't take off like any plane that you've ever seen. It took off in a zigzag path, as fast as you could make a zigzag with the point of a pen on paper, and whooshed out into space. And it was gone. Lots of witnesses saw it. So I don't think I was smoking weed at the time. In fact, I was 13 years old, so I wasn't doing that. There's some other stories in there, but you'll have to buy the book to find out about one of them.
So we got to the part where your dad was hitting a brick wall, not being able to get funding, and he sort of gave up on it. And there was the 1990s work with Hathaway with this machine, and then there was the 1994 replication where they saw 80%. What happened during that experiment? What was the setup like? I know you were going to go there and record it, and then there was a breaking.
Oh. There was a falling out.
There was a falling out. Let's just start from the
with his partners there. Yeah.
So he found some partners and just lead with that, and then what happened since 1994 and onward until we met. That would be
okay. So let's resume the story. After 1994, a promising experiment, not a conclusive experiment, but very promising, suggested it would be worthwhile to repeat the 1994 experiment. And I started looking in Silicon Valley. Daniel was looking for backers. Fred was looking for backers. But as the years wore on up to the year 2000, Fred just, I'm afraid, he lost the physical energy that he had had up until that point. And he told me at one point I could no longer lead a project like you're envisioning here. And I said, what about working remotely with it? And he said, maybe. So I kept looking in Silicon Valley. I guess the peak of my efforts there was when I spoke to Steve Jobs on the phone. Interesting story there, mutual friend. I had first met Steve Jobs right after Apple went public at Frankie's, Luigi's, and Johnny's. And he was not particularly friendly, but that was the way he treated everybody. So I knew he wasn't very approachable. Certainly if I saw him all the time in Palo Alto. If I just walked up to him, he'd probably just turn his back and walk away. But we had a mutual friend who was a street person in Palo Alto. His name was Barry. And I haven't spoken to Barry in many years. I hope he's fine, doing fine. But he was the one who talked to Steve and recommended that Steve talk to me. And then one day the phone rang. I was cell phone. And it was Steve on the other end. And we were talking about some of the objections that investors had. Steve listened to me for a little bit, and he said, "What you're talking about is anti-gravity, isn't it?" Almost like an accusation. I said, "Well, yes, in a manner of speaking." And he said, "Well, if there was something to this, wouldn't Stanford have done something about it?" Actually, no. Stanford would fall on their swords before they do anything about it, just as, not me, but Dr. Maurice Garbel said, there's no university that would let your theory in the door to do honest research on it. So Steve was wrong about that, but how do you explain that without, you know, a little understanding, a half an hour lecture really about the whole thing, what he's dealing with there. I just wanted him to talk to Fred because Fred could be very convincing without even trying. He just sounded like the voice of authority. In fact, I think we're going to post a couple of lectures about special relativity soon, and those are brand new. I think Fred's lecture on gravitation has been published elsewhere, but these are brand new. And the relationship... What's that?
What did Steve Jobs say?
Thank you. What did Steve Jobs say? Well, he said he was very negative about the whole thing. He declined to speak to Fred. And I said, can I at least send you the supporting papers? Because I felt that if he looked at Fred's theoretical work, he would be convinced and he would give Fred a call. That didn't happen. And I never heard back from Steve Jobs. That was over. And I was very disappointed. I had to improve my pitch, I decided. That's one thing I hope to do by going to the venture capital meetings. But every investor had a reason not to get involved. And either they thought they were going to be fooled or it was money. Sorry, what?
You're fine.
I'm okay?
Yeah, you're fine. His hair was in the light.
Oh, I see.
Oh.
So,
And now you're standing in front of the
Oh,
light.
now I see what you're talking about.
Yeah.
Okay, go ahead.
so it's not that easy to find investors. Many investors would approach with skepticism. They'd talk to Fred. They'd become convinced. But at the point where it came to signing a check, they would run away. Because this was so speculative. This was so much like science fiction. This wasn't an incremental extension on existing technology. This was projecting the Silicon Valley semiconductor revolution into space travel. That's quite a leap.
And these were investors that threw millions of dollars away to the garbage.
One of the okay, Mark brings up the point of the fact that millions and millions of dollars were wasted in Silicon Valley on frivolous projects. That was brought home to me in the year 2000 when I went back to Silicon Valley to once again work with Jeff Raskin, the guy who created the Macintosh computer at Apple. It wasn't Steve. But working with Jeff was always a pleasure. Silicon Valley had been transformed by the influx of money, vast sums of money into web page industries, which have taken their place in commerce around the world now. But they weren't that way in 2000, and a lot of people lost all that money, and their companies went belly up. So they had millions to invest, but not in something like gravity control. Whether or not you named it anti-gravity, it's pretty obvious it was anti-gravity. So that's how the money wasn't available for anti-gravity or for gravity control. And the years went by. Fred wrote some great papers. He wrote a unified field theory paper in 2003. He wrote a paper about dark matter, his final paper in 2010. And in 2012, he contracted cancer as a result of metastasized melanoma. Just a tiny spot on his shoulder, went into his bloodstream, got lodged in his lung, and he had inoperable cancer by the time I made it up to Oregon the next time. And in December of 2012, he died. Devastating blow. I thought my entire life, I thought, well, Fred's going to make it. Somehow he can't fail. He succeeded in aerospace so well. He succeeded in breaking through the riddles of heat conduction and turbulent flow and optical riddles, Sommerfeld's effect, all of these things he'd done so well. He couldn't fail to find a slightly visionary investor to work on gravity control. But we did. We failed. And Fred, subject to the laws of physics like we all are, he died. And now I had to figure out what to do. And I decided I was going to take Fred's experiment, 1994 experiment, and take it back to academia. First place I wanted to go was UC Santa Barbara because he had been employed by the physics department at UC. And there I experienced for the first time the brick wall of academia. They would not even discuss it with me. I took the precaution of not sending them the experimental report. I didn't want them to know the details. If they wanted to talk to me, I would have brought it out, but they did not even want to talk to me. And by the way, UCSB was my alma mater, and I thought that would pull, I'd have a little pull there. Very little, but some with the physics department, based on my dad's employment there. No, none of that mattered. It all had to do with the rejection of general theory of relativity and the idea that you were working on controlling gravity, which everybody knows can't be controlled. Certainly not by electromagnetism. And that's what I encountered at all the academic institutions I wrote to, and I wrote to a lot of them.
Did you mean rejection of special theory?
No, general relativity. Fred rejected...
Is rejected, okay.
Yeah, Fred rejected general relativity as a starting point for, again, amplifying the range of special relativity by using a more realistic light signal as the basis for the metric. But this yielded the theory of gravitation that he stuck with from 1960 to the time of his death. Okay, so first group of people I struck out with were academics. Then I decided to think a little more creatively, and I went to SpaceX and Virgin Galactic and a number of other commercial space exploration companies. Never even received one reply to inquiry letters from them. Bureaucratic organizations dedicated to rocketry, I don't take it personally. The job of a flapper is to keep the crazies away. Maybe I sounded like a crazy because of what I was talking about. Or maybe I just sounded like somebody who'd upset the stability of the rocketry research programs that were already in place, causing people to lose their jobs. It certainly wouldn't have happened that way, but they did not even want to talk about it if they ever even saw my letters. It's quite possible they wound up in the round file immediately. So what then? Well, I thought maybe a Hollywood company that did a show, something like the Oak Island Mystery, would want to do something like this, where we would mount the experiment and the suspense would be created by the build-up to the experiment. And we could do all kinds of things about UFOs with CGI simulation of UFOs and show how they worked. What was the pulsing heart of a UFO in flight? And we would show exactly what it was, right down to the numbers. I could not even make contact with these groups, and I went through agencies that handled shows like that. Never heard back. So now I was kind of at a loss. Finally, I approached David Copperfield, the magician. I said, how would you like to throw a SUV through the air like it was a tennis ball? Real magic instead of stage magic. I thought it would intrigue him, but never heard back. Nobody wanted to talk to me about it. And at that point, I decided, okay, I've got a $1 trillion invention here. $1 trillion invention here. I'm going to write up everything I know about it, and then finally I can put it out into the world and I'll be done with it. Because I didn't expect the world to respond to it, respond to the books. And I put out 2 books. I put out the 2 that I've showed already, but I'll show them again. This first one was Gravity Control with Present Technology, which included everything I could that hadn't already been published. And then the top 10 riddles of flying saucer flight. I didn't think it was a good idea to combine them because they were too... This is all about science, not about UFOs, and this is all about UFOs and secondarily about the science. So, I think it was the right decision. There was actually some feedback on the gravity control book, but nothing substantial. Nobody seemed to want to mount a project on it until I heard from Mark Sokol. And he wrote to the email address in the back, which is, I don't think is any good any longer, but I did get Mark's letter. We had a few phone calls, and the more I talked to him, the more I thought he was serious about remounting the 1994 experiment. And he also seemed to be willing to bring in experts where his knowledge might not cover all the bases. And he has done that all the way along here. So now we have an experiment almost ready to be run, and I'm out here to see it if all goes well. But I want to say in advance that, and Mark agrees with me on this, whether or not the experiment is successful. If it is successful, it'll be a fantastic event worthy of international coverage. If it doesn't work, as scientists, we don't necessarily abandon the theory behind it, because especially since 1994 worked exactly as predicted. Instead, remember the layers of science: the theory, and then the hypothesis, and then the experiment. And the experiment has to control all the variables, and the devil is in those variables. You have to be able to split things apart to a very fine level, a finer level than most people would even consider, and look at every single one of those variables as a potential wrench in the works. And so it simply means we go back and adjust some of those variables and hope for a better result the next time. We'll all be happy if it works the first time, but we don't give up just because it doesn't work. If it's successful, though, it's going to be uncorking the champagne bottles time. It'll be a big day in the history of science. And that's what I hope it is. So I'm very excited about this, and I'm very happy to know Mark, and what he's done here is pretty incredible. His energy is out there, outstanding. So I think I've come to the end of what I need to say, and I thank Mark and Tammy for the opportunity to say it here. Okay, I've been asked to explain the connection between the technology of dynamic nuclear orientation and anti-gravity, for want of a better word, or gravity control, which I prefer, and which Fred learned to prefer, my dad. So, first of all, you need to begin with some theory of gravitation. You have to have some idea how it works. And here we depart from the model of general theory of relativity by Albert Einstein. And we go straight into my dad's theory of gravitation, which was More in the tradition of classical physics, because it referred to known forces rather than the abstract form of curved space-time. So we're not going to argue the truth or falsity of Einstein's general theory of relativity. My dad was a great admirer of Albert Einstein. Instead, we're going straight into the heart of my dad's theory as an alternative. And his view of reality is right in line with the development of physics. His view of reality is right in line with the development of physics from the period of James Clerk Maxwell up to the present. Namely, as we look at the history of physics, it's a process of finer and finer filters, looking at deeper and deeper layers of reality. I mean, everybody is quite acquainted with the visual layer of reality. We see the room around us, we see the stars above us at night, we see the ocean and the mountains. These are gross material objects, but if we look deeper into them, we find that they're made up of particles, namely molecules and atoms, and that's another layer. Below that layer is another layer called the layer of elementary particles. And it's here we're going to focus our attention. So what we observe about gravity is that it's found anywhere in the universe that there's a mass, an accumulation of particles. And the greater the mass, the greater the force of gravitational attraction. It becomes very dramatic when it's the attraction of a planet for another celestial body, or for you standing on the surface of the Earth. But truth be told, and it's acknowledged by all scientists, any object has a gravitational field. All objects that have mass have gravitation. Now, it doesn't matter what kind of mass you're looking at. It could be hot, like a star. It could be cold, like planet Saturn. It could be a mass of a gaseous cloud, a nebula. A nebula, even being insubstantial, is big enough, there's enough mass in it for it to attract other objects. So what we're looking for a common factor among all other objects if we're going to find a physical cause of gravitation. So what my dad asked us to consider is that the common factor in all kinds of mass is elementary particles. No matter whether it's hot or cold or large or small, elementary particles is one feature of all mass that it has in common. So then he looks at, in classical mathematical style, he looks at two elementary particles and represents them by two bell curves. Because an elementary particle is not necessarily something you can visualize, it's just a little clot of energy, and this energy is concentrated in the form of a knot, and then it shades away from the center in terms of the amount of energy it has into the distance. How far into the distance? Even an elementary particle has a field of energy around it that extends to infinity. Of course, it's very slight, but this field is made up of what my dad termed virtual processes. He's not using the term in exactly the same sense you'll find in physics books, where even the reality of virtual processes is argued by some physicists. For my dad, there was no argument, and he cites this sources within the book Gravity Control with Present Technology. Too deep for us to go into here, but let's just say it is a generally accepted fact that the virtual processes surround all elementary particles. So this is yet another even finer layer of reality. Virtual processes is simply a field of random electrodynamic activity where elementary particles are being created and destroyed on an infinitesimal scale of time and space. And the density of activity of this cloud of virtual particles shades away from the center of an elementary particle into the distance, and likewise from the mass of the Earth into space. In other words, I'm about to explain why the virtual process cloud that surrounds the Earth is the gravitational field. It's not causing the gravitational field, it is the gravitational field. So let's go back to our two particles. Where they overlap, their energy fields overlap. Let's picture them as two bell curves, and now move them their centers closer together. There's an overlapping area between them where the mass of each particle is increased by delta m, a small amount. But from the standpoint of the diameter of the particle, which is expressed by a very simple mathematical expression, Planck's constant divided by mass times the speed of light. You're no longer dividing by mass times the speed of light, but mass plus delta m, that shaded area in the middle. So the diameter of each particle contracts in response to the energy added by the points where they overlap. Now this delta m also occurs between the planet Earth and your body, my body, and all objects with mass. We interact with the Earth's virtual process cloud, and the entanglement, the overlapping, causes an attractive force, which he reduced to Newton's force law in several of his papers. So it is mathematically described, and it just happens to be exactly the same as Newton's force law. Now, we come to the method of overcoming the gravitational field, since we have a broad, rough description of what causes it. What I'm going to do is start with the punchline. The process is analogous to a well-known method of cryogenic freezing called adiabatic demagnetization of paramagnetic salts. I'm going to describe that, and then I'm going to describe dynamic nuclear orientation and how it can do exactly the same thing with gravitation. That is, we have cooling of heat by reducing the kinetic energy in an object, the molecules making up an object, and we have reducing the gravitational field by reducing effectively the kinetic energy in the gravitational field by reducing this random activity of random electrodynamic activity at the level of virtual processes. And mind you, nobody's been able to observe virtual processes because they're much too refined, too fast, too transient to observe, but we have observed their effects. And that is also something gone into in the book. I'm not going to get into a digression on that here. Let's just talk about, first, cooling of paramagnetic salts by adiabatic demagnetization. I'm going to use my father's words. If you'll pardon me, I'm going to quote from the book. This was some notes I found in the back of one of his notebooks, not published anywhere. Cooling of a paramagnetic salt by adiabatic demagnetization. A constant magnetic field is applied to the specimen, which may have been previously cooled by a convenient means. The field aligns the elementary magnetic dipoles of the specimen, which work on the rest of the specimen, raising its temperature. This is important. The temperature of the specimen is raised at first when you apply a magnetic field to the magnetic dipoles of the paramagnetic salt. I'm going to go back to the beginning of this quote this is a quote from my dad's notebooks, not published anywhere except in the book, Gravity Control with Present Technology. He says, and I'm sure this was a draft he was preparing for publication since it was never published. It is the purpose of this exposition to compare the cooling of a paramagnetic specimen by adiabatic demagnetization and the cooling of the gravitational field by dynamic nuclear orientation. These are certainly not one or two syllable words, but they're easily translated into plain English. What he means is turning on and turning off a magnetic field in the presence of paramagnetic salts. That paramagnetic salts are weakly affected by magnetization, by a magnetic field that comes close to them. Okay, so they're weakly magnetic. These will be compared in detail with numerical estimates of the quantities introduced so as to clarify the process of reduction of the gravitational field. He's talking about cooling the gravitational field with dynamic nuclear orientation. Okay, first step. A constant magnetic field is applied to the specimen, and now we're talking about cooling paramagnetic salts, which may have been previously cooled by a convenient means. The field aligns the elementary magnetic dipoles of the specimen, which work on the rest of the specimen, raising its temperature. Raising its temperature is an important part of this process. You will see the weight of the object raised by dynamic nuclear orientation when you start one of the cycles by which you remove the gravitational field. First it goes up, then it goes down. This is what was observed in 1994, providing a pretty strong confirmation of the predictions of the theory. Okay, step 2, the specimen then comes to thermal equilibrium with its surroundings. So remember, it was temperatures raised, now it comes to thermal equilibrium. The temperature is the same everywhere. That means, by the way, temperature is a measure of the kinetic activity of the molecules in the specimen. That is, they're jittering. Step 3, the magnetic field is removed suddenly. Yeah, that is quickly in comparison with the molecular processes which conduct heat to the specimen. In a time interval small compared with the time required for a molecule of the environment to traverse one mean free path. The elementary dipoles of the specimen are left oriented. Now, mind you, there are two elements to the cooling by adiabatic demagnetization of paramagnetic salts. There are the magnetic dipoles, which are being worked on by the magnet, and then there's the surroundings. This is similar to the, say, your flying saucer and your surrounding gravitational field, as we'll see. Okay, in step 4, the thermal collisions of the surroundings perturb the orientation of the oriented dipoles, causing them to lose their orientation and in the process lose some of their energy. The loss of energy described in step 4 above, which is worth discussing in some more detail. This is short. The surroundings in equilibrium are composed of molecules colliding with one another in a chaotic manner. That's what we're looking at with the virtual processes, the random electrodynamic processes of the virtual process cloud surrounding the Earth. Same thing, analogously. Colliding in a chaotic manner with orientations distributed in a random manner. Orientations mean, say, the magnetic dipoles are pointing north and south, and in their surroundings they're pointing every which way. That's the meaning of random. But in the magnetic sample, paramagnetic sample, they're all pointing the same way. Now you take away the magnet and suddenly they start to get disoriented. What's disorienting them? Their surroundings. The surroundings are doing work on them to shake them up and randomize them. The whole system, on the other hand, is losing energy. And that means it's losing temperature. Then you do it again. All the steps above, you do it again rapidly. And rapidly, the temperature of the sample sinks toward absolute zero. It seems impossible, but this process has been known since the 1920s, and it can lower the temperature of a sample to close to absolute zero within one incredibly efficient process. And we expect to see the same thing with the Earth's gravitational field. So here's dynamic nuclear orientation. And this should satisfy the curiosity of many people who have asked, why dynamic nuclear orientation? Why not an anti-gravity beam? Well, gravity doesn't have to do is just bleed energy out of it, cool it down, and release our craft, which, by the way, should be shaped like a saucer, as was discussed in an earlier video. Okay, here we go, dynamic nuclear orientation. In reducing the force of gravitation by dynamic nuclear orientation, the procedure is analogous to the above. Step 1, a constant magnetic field is applied to the specimen. This field causes the electrons in the specimen to precess with the Larmor frequency. The Larmor frequency is the speed with which the axis of the electrons, if you can imagine them like tops that you played with when you were a kid, is turning around and around and around in a circle around a single point like this, precession. Gyroscopes do it too. Okay. The electrons should be in penetrating orbits. The electrons should be in penetrating orbits so that the precession can be carried to the nucleus of the atoms. In other words, these electrons are in close contact with the nucleus of the atoms, and they're much lighter than the particles in the nucleus of the atom. What we're going to do is use them as leverage to create the same polarity and motion with the elementary particles in the nucleus, protons, neutrons, the usual components of the nucleus of an atom. All right. Then a microwave field, this is step 2, a microwave field of the same frequency as that of the precession is applied to the electrons, these little tops precessing like this, all of them precessing in the same axis, to flip over and in turn cause the nuclei of the atom to turn over. So we've leveraged the power of the electrons to affect the nucleus. Dynamic nuclear orientation. We've oriented the nuclei. At the same time that we orient the nuclei, we impart a directional factor to the virtual processes surrounding the elementary particles in the nuclei. Now, this is kind of a billiard ball explanation, but remember that we characterize an elementary particle as a bell curve of energy. It's this outer skirt that is getting a directional quality. It's usually, the outer skirt is usually moving randomly. Now, because we've flipped the elementary particles, aligning them all with the movement of the electrons nearby, then the virtual process clouds are momentarily organized where they weren't organized before. So let's continue. Step 3, the magnetic moments of the nuclei and electrons are conceived as consisting of 2 parts. This is my dad expressing pretty much what I just expressed in more scientific language. A hard core of dense circulating electric currents, essentially responsible for the usually measured values of magnetic moments. And B, a cloud of electric charges due to the virtual processes, which are not as tightly bound to the hard core as the currents making up the core. Okay, step 4, the orientation of the nuclei and electrons induces orientation of the virtual charges as well as the hard core. This is what I mentioned before, and it's worth repeating in other words. Since most of the mass of the atoms is due to the nuclei and virtual processes are responsible for the existence of inertial mass. This is also part of my dad's theory. The same random electrodynamic processes are responsible for inertia and for gravitation, which, by the way, explains Einstein's equivalency principle. Inertia and gravitational pull are the same.
So tell me a little bit about your father's theory on gravity and how it relates to dynamic nuclear orientation.
Well, first of all, the theory that the theory of our technology derives from actual objects that are flying around above us. What we refer to as UAPs, virtually all of their flight characteristics are explained by this theory. However, I'm going to give you a very abbreviated version of the theory, beginning with the way the gravitational field works, according to my father's theory, and the pedigree of that theory, which I won't go into, is very high, coming from a friend of Albert Einstein's, Victor Lenzen, and J. Robert Oppenheimer, and some authorities. So it's not one of the weird theories out there. It's actually in line with classical physics. Now, in just a few words, how it works. If we can prove that two particles attract each other, then we can understand the mechanism that attracts zillions and zillions of particles in the form of a planet to a larger object like the sun, or attracts us to the surface of the Earth. It's a mysterious force because it is always there wherever you have mass. And nothing can shield you from gravity. No effective shield has ever been found. And no connection has been found between gravity and electromagnetism. So that's going to be the punchline of this riddle. How are we going to use electromagnetism to alter the force of gravity? Comes out of the theory. Okay, so we have two particles. They overlap. And from particles are not solid objects like billiard balls. They are little knots of energy that have, they fade out the farther away you get from them. But if you bring two of them close together, they overlap. The energy skirt, which is bell-shaped curve. Let's picture it overlapping. There's a shaded area where it overlaps. This disturbs the equilibrium of the two particles, and in order to adjust, according to Le Chatelier's principle from chemistry, oddly enough, but this principle states that when you disturb the parameter of any parameter of a system, and we have a system and we have these two objects, the rest of the system will adjust to establish equilibrium again. This effort to establish equilibrium results in an attractive force between the two elementary particles. Elementary particles being electrons, protons, positrons. It doesn't matter what they are, and that's an important feature of gravitation. It doesn't matter what kind of mass, what kind of particles the mass is constructed with. It's only that there is a mass. And our theory doesn't require more than that. We just need two elementary particles of any kind close together, and an attractive force will be generated. This force is very weak between two particles, but multiplied by the number of particles in a planet, it becomes very strong, strong enough to hold the moon in orbit around the Earth, or the Earth in orbit around the sun. Now, if if we want to alter the force of gravitation, we want to alter the virtual processes that are held to be responsible for it. That's the name for the energy on the outskirts of an elementary particle, and likewise surrounding the Earth in a blizzard of virtual processes. Virtual processes might be described as the creation and annihilation of subatomic particles on a subatomic plane. When we say this happens fast, it happens not blindingly fast, but faster than blindingly fast. A one with the negative 14 digits after it covers the time span, the lifespan of a virtual process particle. Okay, so how do we alter the energy between ourselves and the Earth, for example? What we want to do is reduce the interaction between the Earth's virtual process cloud and our own virtual process cloud, which pervades our entire body. The method is dynamic nuclear orientation. Dynamic nuclear orientation is analogous to a cryogenic freezing process called adiabatic demagnetization of paramagnetic salts. And the analogy is pretty darn good. So let's look at these paramagnetic salts. You magnetize them, and then you release the magnetic field, and the surroundings do work on the paramagnetic salts to cause them to move, and in so doing, reduce the kinetic energy in the system, in the surroundings plus the paramagnetic salts. Likewise, with dynamic nuclear orientation, we orient the elementary particles in the atoms of our bodies and the vehicle that we're in, and then let the Earth's gravitational field do work disorienting them. We do this millions of times per second. So each time we do it, we reduce the kinetic energy in the system, in our immersion in the Earth's gravitational field. And what we would expect to see on a chart that graphs the weight of our vehicle is each time we applied the microwave cycle to set up the elementary particles in the nucleus of the atom, cause them to flip over and stay in one line, we would expect the weight to go up. And as soon as we shut off the microwave field, we would expect to see it fall, because that's the moment when the Earth's virtual process cloud is doing work on the virtual process clouds of our elementary particles and losing energy as a result. So slight spike in weight and then a precipitous drop. We cycle it again and there's another spike in weight and even more drop as we build up orientation in our craft being something like a hot air balloon or a reservoir of orientation, and the Earth's magnetic field wearing itself out saying, disorient yourselves, you dirty particles. So that is an energetic conflict. The Earth's gravitational field loses, and we gain complete weightlessness and freedom from inertia. We can expect such a vehicle to fly exactly like the UAPs and the UFOs have been described as flying for years, in defiance of all the laws of physics. In other words, right angle turns, no problem. We don't have any inertia in our bodies, so we won't get mushed against the side of the flying saucer. Instant takeoffs to Mach 10, no problem, because we won't feel any acceleration inside of our craft. And Earth to space in seconds, no problem, because nothing's resisting our leaving the planet. And a very small amount of energy is required as propulsion to take us out into space. Here's an anecdote. My dad used to say, if he was able to attain complete weightlessness for ourselves sitting in a bathtub, all he would need to get to the moon would be a can of hairspray. And that's true, as a matter of fact. So think about that next time you're out looking at UFOs flying overhead. They're not especially weird or supernatural technology. They are simply flying toaster ovens.
Can you give us a little description of this machine that's behind us and how it relates to dynamic nuclear orientation?
Sure. Sitting behind me is a electron spin resonance machine. Am I correct about calling it that? Electron?
Yes.
An ESR. It was manufactured by Varian. It's called an E3 EPR, electron paramagnetic resonance spectrometric device. Okay, and on my right here, on the right of the machine are two very powerful magnets, and they are designed to carry out part of the dynamic nuclear orientation process. What they do is, since they're so powerful, they can orient the electrons of the sample around the same axis, and then this part of the machine generates a flash of microwave energy, which causes the electrons, which are precessing around the same axis due to the constant magnetic field, to cause them to precess so violently they tip over and they orient the nuclei of the sample material. And that's dynamic nuclear orientation in a nutshell. Well, Dave, you might ask me, how come we haven't seen any of these devices float off the table? Well, they've never been set up with the right recipe. What we're adding here are little details that make all the difference. For example, the pulsed microwave energy is not typically a feature of these devices. And certainly not at the frequency of pulsation that we've chosen, which was given to us, ironically enough, by our friends from who knows where in their flying machines in 1957, when they were observed flying over the Gulf of Mexico by a B-57 US Air Force electronic countermeasures surveillance training mission with a passive antenna on board, which recorded 3 gigahertz frequency and a pulse rate of, I believe, 0.03 seconds. We're going to try a variety of combinations of these frequencies and pulse rates, and we expect to see our samples lose weight precipitously. This was tried in 1994 with success, but we want unequivocal proof this time. This machine is part of achieving that unequivocal proof.
And was this machine used by your father and your brother at some point while working on this?
Was this machine used by my father and brother? Yes, in a laboratory in Toronto with the collaboration of engineer George Hathaway. And he's mentioned this online, no secrets there. The experiment used a different material, ruby crystal. We're going to be using aluminum. We expect to see more dramatic results with aluminum, as we did in 1994. And yes, my brother and my father were both hovered over this machine in 1990 doing experiments on this technology.
And also, this device will never fly even if it's successful. It's only the sample, right? The sample inside that little waveguide that's going to see it.
Okay, we don't expect to see the effect spread beyond the sample. It would take another kind of technology to do that. So what we actually have in mind is setting up 2 parabolic antennas clapped together in the middle with a microwave generator in the center. Thanks for the prop, Mark. Here's your parabolic antenna number 1, and it's broadcasting microwaves, radar. This is a perfect shape for a radar antenna. Here's number 2, and we bring them together. We put a seal around the edge. We turn on our microwave generator and start flashing it. And pretty soon the entire shell is ready to take off. As has been seen countless times before by people who were told, you're crazy. Not anymore. We're going to build our own flying saucers.